Bismillahirrahmanirrahim. Assalamu alaikum. So now let's do some examples based on simplest version of Ito lemma. Suppose we have a function f of x equal to x square, and I want to compute what is the differential of, or maybe I am writing it in the variable x, but you can assume that it is the function which is depending only on Brownian. So I want to compute what is going to be this differential. What is this differential? So I need to recall my simplest version of Ito lemma. Why simplest version? Because it is only depending on the Brownian motion. So my simplest version of Ito lemma said that your differential of any function which depends on only Brownian motion is going to be equal to its derivative dbt plus minus 1/2 and its second derivative at Brownian dt. So I need to compute first derivative of this and second derivative of this. So its first derivative is going to be 2bt square, and its second derivative is going to be, of course you know from your basic calculus, so it's going to be only 2, because it's 2bt and then it should be 2. So you just need to insert these values into the simplest version of Ito lemma. So it's going to be, here I'll put this function's value bt square equal to, so first derivative, which is 2 times b of t, b sub t dbt minus 1/2, it's basically plus 1/2 second derivative, which is 2 dt. So from here I can write the differential of bt square is 2bt dbt plus dt. So that's the differential of b of t squared. Now this is interesting, expression, because if I integrate this both sides, then I can compute a very nice Ito integral. How? Let me show you now. So now let's integrate this expression from a to, let's say, b. So let's integrate this from a to b. Okay, a to b, 2 times b sub t db sub t plus a to b dt. And now this left side gives me b sub a squared minus b sub b squared minus b sub a squared. Is just, the differential and integral as they behave. So this differential goes away with this integral in rough and informal way. So it's going to be 2 times a to b b sub t dbt plus b minus a. So you can take this b minus a to this left side, or you can take this term towards the left side and this term towards the right side, or you can say that just rearrange this. So you get 2 times a to b b sub t db sub t equal to b sub b squared minus b sub a squared minus b minus a. So you just take this 2 towards the right side, so you will get this a to b integral of this Brownian with respect to Brownian is equal to 1/2 of Brownian computed at b squared minus Brownian computed at a squared minus b minus a. So you have computed this nice Ito integral, which we have already seen and as example in the previous videos, but now using simplest version of Ito lemma we can compute the Ito integral of a Brownian motion with respect to Brownian motion. I'll reiterate this, that in some books this b of t is represented by w sub t, so you don't need to confuse with this. If they are writing w of t in place of b sub t, so you just replace w sub t, or where it is b sub b, so you will write that w sub b. So that's not a big deal, I'm sure. So that means we can compute the differential of a function or certain Ito integrals using simplest version of Ito lemma. Let's meet in the next video with another example.